How are y'all doing? Apparently, I'm Chris Gardner. These things happen. This is Rethinking Architecture, an introduction to macroservices. Before you get too optimistic, macroservices are a joke, but the content is real. So we got to start off with our obligatory, narcissistic slide. I'm Chris Gardner. I am a Microsoft MVP. I work for a little company called Accenture that you may have heard of, and I also run a conference down in Alabama where I'm from. We all good? Yay! All right, I know it's like 10 in the morning, but wake up. All right. Or maybe it's because you have the cushy seats and I'm up here pacing. But yeah, okay. Anyways, there are a couple assumptions we're going to have before we start this talk. Keep in mind, if you fail any of these assumptions, there is still valid content in here for you. But having said that, the people who are going to get the most impact are the ones who fit these three criteria. Number one, your job is somewhere between maintaining a low-traffic website at a mom-and-pop shop and working as a senior engineer at Amazon. Right? If you're a senior engineer at Amazon, there are reasons why you're doing microservices. If you're doing a very small mom-and-pop low-traffic site, just have the monolith. It's a lot easier to deal with. We're thinking you're somewhere in the middle. Everybody good so far? Do we have any quote-unquote senior engineers at Amazon in here? I gave this talk once, and someone who's a senior engineer at T-Mobile was in the room, and I'm like, you're going to be interesting for the rest of this session, let me tell you. All right, number two, the point here, boss doesn't make choices for you. Because, sometimes it's like, ooh, this is cool stuff, I love the way you're doing stuff, but your boss is never going to let you do anything. I'm assuming you have some autonomy in what you're doing. And number three, your tech stack doesn't make decisions for you. Anybody know of a good decision of where your tech stack makes decisions for you? No, .NET Framework gives you a lot more freedom, and that's not just because I'm a .NET dev. But things like Django, Ruby on Rails, where it's like literally you have to do it their way, or things just don't work. There aren't too many of those these days, but it used to be a bigger deal the first time I wrote this talk. We're not going to mention how long ago. All right. Normally here we do a nice little survey just so I can read the room. But considering we're in 3 different rooms, I don't know how well this is going to work. But just kind of, we'll play this by ear. So how many of you are currently devs? Most of you, okay. How many of you have been doing it for about a decade? Got some old timers? We got any really old timers? We got any super old timers? Sweet. Anybody that's before me? Okay. So we've got a good mix in here. But just in general, how many of you have just been programming for ages? Right? We're just going to go down quicker. Right? So, cool. So we've got lots of skill ranges, lots of everything in here. Because sometimes you get grizzled old veterans like me, and I just miss the good old days when things just didn't work. Now they don't work still, but it's in new and interesting ways, right? I miss the old ways things didn't work. So we're going to start this off with a brief history of time. Don't worry, those will get blown out into individual slides later. Don't worry about reading that one. Because I think to really have the discussion we're going to have about architecture, we need to understand how we got to where we are, right? Everybody on board? So, what do we want? We want something that's easy to develop and maintain. We want something easy to test. We want something easy to install and deploy. And we want something fast to perform it. Everybody on board with at least those 4? All right, what am I missing? Cost? Yeah, I'm a dev. I don't care about cost. Now, as a senior architect, I care about cost. But as a dev, I don't care about cost. Observability? Maybe. Scalability? That's DevOps job. There's a whole section about that, sir.
I'd say it needs to be easy to pass down to someone else.
Ooh, that's one I haven't heard before. Wow. Maintenance? Well, yeah, easy to maintain is kind of in that one, so, okay. Normally the 2 things I get yelled at about is security and accessibility. Security's not my job. It's my job, but I mean. And then accessibility, they kind of all tie into the other parts. So we got to make it easy. But feel free when I start saying, hey, how do we do this? How do we do this? Bring up all those topics you mentioned. This is meant to be a nice open discussion by the end. So that's what we want, right? So how do we get to where we are now? So in the beginning, we had a problem. Big problem. Notice she's not smiling. All right, I'm slightly kidding about how far back we're going. Not really, but I am. But anyways, we eventually turned the punch cards into assembly language, right? And that was better. Note that punch card does not match that assembly language. If any of you in here could read what that punch card does, you are way overqualified to be in this talk. That's all I'm saying. But anyways, but then we go from very sad person to smiling person, right? Because you didn't have a program that stopped working if the fan got turned on. This was a real thing, people. Anyways, so then the assembly turned into a high-level language. Fun fact, for an x86 processor, that assembly language does match that C code. So that is the actual assembly language that C code will produce. I also like using that code because it contains my favorite line of all programming in it, which is x equals x plus 1. We call that the fundamental lie of computer science. I also have a degree in math, and that line of code makes me squirm every time I see it. That's all I'm saying. Yeah. Anyways, we got greedy. So we said, what if we took really large problems, but we treated them like really small problems? How many of you just squirmed and said, he's talking about me when I said that? Some of those laughs were not as jovial as the others. That's all I'm saying. So we didn't want to change. We wanted to declare everybody do everything. And so we ended up with spaghetti-oriented architecture, like AKA copy pasta. This is the 90s, man. I mean, I cut my career on this stuff. And the people who maintained them were revered as gods. And that's an even funnier slide if you get the reference of what the picture is. I'll give you a hint. It's a game called Dead Space. So let's consult our checklist, right? When we had these big monoliths. Were they easy to develop and maintain? Well, no, because we didn't know what we were doing. Let's be honest, all right? Were they easy to test? We didn't test things back then. What, are you crazy? God, you gave us way too much credit in the 90s, let me say. If you ever wondered why old-timers don't even like using baking apps or stuff like that, this is why. Were they easy to install and deploy? Yes, because he put it on the disk and said run the program, and it just worked. Strangely enough, that was the only thing we got right back then. And were they fast and performant? Comparatively speaking, yes. Remember, lower your expectations. Am I using a calculator to add up 100 lines in a spreadsheet, or am I just saying sub this for me? That's all the expectations we had. So comparatively speaking, we're actually not that bad, right? We're talking so far back. This is before the Agile Manifesto, which was 2001. This is before Solid Principles, which was 2000. This is before software engineering and architecture was even seriously talked about. The first papers on it was about 96. That one's harder to pin down. We're talking before the design patterns from the GAGA 4. Of course, now we know that all those design patterns are wrong anyways, but that's a whole nother talk. Fight me. We're talking about before Mosaic, which was the first web browser in 93. We're talking before Windows for Workgroups, which was the first major operating system available to the masses. I did qualify that had networking built in. Yes, Unix had it for ages, but how many of you had Unix at home in the early 90s? How many of you had U at home in the early 90s? Okay, a few people, good. So when we keep all this in mind, of course, all that goes out the window. Of course, we still weren't testing, but that's beside the point. Quick side note, we did go to thin clients for a while, which kind of did some other architectural stuff, where we put everything on a server and then just had clients connect to it, but they ran everything off the server, which fixed some of our problems. But what does this sound a lot like? No. A web browser, right? Everything old is new again. All right. So, yeah, it got easier to install when we just had to put it in one place. But then all these things started to change, right? So all of that stuff started to happen. And we could add a few more things to it, which were Ajax and SOAP, right? And let's give the devil his due. Where was Ajax first introduced? A little web browser you may have heard of called IE6, yeah. As much as we hated it, it was really important to getting to where we are today. But as we moved all this stuff to the thin clients and got it up to the servers and turned everything into a web page, we get interior design and service-oriented architecture and our lasagna layout, right? And we were happy. We were very happy at the time. So let's reconsult our checklist, right? Were these things easy to develop and maintain? No. Not really. I mean, even as somebody who was there as it was happening, it was still hard to wrap your head around, and it still does a few things pretty bad. But was it easy to test? Actually, yeah, because this is when we started splitting things off so we could kind of isolate things. So it made testability pretty good. All right, was it easy to install and deploy? Yeah, because it was in one place, right? It was back to our putting things in one place. Was it fast and performant? No, not really. Because everybody was used to doing everything local, so now when you're hitting a web page to do everything, and like internet, this is back in your levels of internet. It just wasn't performant. Sometimes you would be like at a client, and they may have 10 gigabit Ethernet. Oh, then maybe it worked. So, but then the problem, oops, there's a cord there. And then the problem came, though, is that we realized that as these things got bigger and more complicated, they quit being easy to install and deploy, right? Because now when you're talking about layers, you're talking about multiple servers, you're talking about things being in weird places. This whole innovation happened, I don't know if you've heard of it, called the cloud. Anybody played around with that? These newfangled people. Right? So we said, okay, we got problems. Let's make everything smaller so that we quit having problems with all these large things where one change affects everything. And we can do everything independently, and everything will be happy. And so we created microservices. I hear something in the next theater. Right? So we have a ravioli-oriented architecture. Everything's good, and everybody was happy now. Finally, all of our problems were solved. If you notice, he misses every now and then. I kind of beta test all my talks on my kids. That's why there's an obligatory My Little Pony slide. All right, so let's consult our checklist for a final time-ish. Were they easy to develop and maintain? Yes, that was the promise, right? Super small, self-contained blocks. Cool. Were they easy to test? Yes, super small, self-contained blocks. Were they easy to install and deploy? Yes, they were super small, self-contained blocks, and you just put them in one place, and we were able to go. Were they fast and performant? Yes, because they were super small, but we're done here, right? No. So you have to remember, this is when we first started. This is V1 of all these microservices. What's the problem with V1? V2, that's the problem with V1. So first of all, let's split things up a little more. We're gonna do develop and maintain separately now. We all good with that? Because microservices were really easy to develop, but they were horrible to maintain. They were so bad to maintain, we created its own job so we didn't have to do it anymore. Remember when I was going to make fun of DevOps? We're getting there. All right. But because of that as well, were they easy to install and deploy anymore? No, because now you had concurrency and changes, and was everybody using the same version? Was everything going back and forth? And then what might be the most controversial part of this slide, it is totally not the most controversial part of this slide. What might be the most controversial part is that were they faster performing? No, right? So what looked like the savior is now almost worse than what we came from. So we moved from dev to DevOps. I promise you, if I was any good at Photoshop, there would be a Kubernetes logo on the Titanic right there. Because, well, I mean, literally, they became so hard to maintain and do everything with. We created an entire new job called DevOps to deal with how badly we messed up the architecture. How many of you are DevOps engineers? How many of you are not laughing at that joke? A few of you nodded your heads. That's all I'm saying. So I love this slide. Hopefully it's not big enough to really see it. But it's a great comparison. It's like, let's talk about speed. So if one CPU cycle was scaled to 1 second, a system reboot would take about 53 millennia. Right? Let's go through some of the high points here. How many of you, can you all read that? Just out of curiosity? No? Okay, yeah. It always depends on the conference if that's going to be big enough. So one CPU cycle, at the time, this tweet is from 2014, but they said 0.3 nanoseconds, which is pretty fast, but we're going to scale that to 1 second. And the reason I like that analogy, just to help you wrap your head around it, is what can you do in exactly one CPU cycle? One calculation is correct, but I was specifically going for add 2 arbitrary integers. Right? That can easily be done in 1 clock cycle. Comes in, comes out. Everybody's happy. You, as a human, if I were to give you 2 arbitrary small numbers, integers, let's say 7 and 4, it takes you about 1 second for those inputs to come in, you to parse it, you to actually do that, and for somebody in the front row to yell at 11, which is correct. I like how I don't even have to tell people to add it. Somebody will do it for me. You're doing a good job, sir. All right, so with this scale in mind, we start talking about cache access, stuff like that. If you're not in the cache on the CPU and you go to RAM, which is about a third of the way down, we're talking it's about 120 milliseconds, which doesn't sound that, or nanoseconds, which doesn't sound that bad. But remember, that scales to 6 minutes. So just being out of the processor jumps a lot. So you got to go to the hard drive, which is that big one over there. Says, well, that's 1 to 10 milliseconds. That's not that bad, right? That scales to 1 to 12 months. It takes you a year to go to the hard drive. And it does specifically say rotational, right? That's if you've got a platter. But here comes the fun part. You ready? Internet from San Francisco to New York. What's a good ping time? If you're not a gamer, what's a good ping time? 100 milliseconds. You are super forgiving. We like that guy. They use 40 milliseconds on here, right? So 40 millisecond latency. 4 years. If you've got to hit the network with a really nice ping time, and here we're just talking physics, right? We're talking years in comparison to keeping something in process. And then, of course, at the end, physical system reboot, which takes 5 minutes. That's like 32 millennia, right? So, how did we get there? What went wrong? We longed for simpler times. I love that tweet. How many of you, the first microservice you wrote was because of that? Admit it, it was mine too. Yeah, there's a couple. All right. So where do we go from here? I'm going to warn you right now, the next slide is the worst joke in this entire slide deck. It's so bad I warn people about it. But really, we do have to meet in the middle. Yeah, I went there. So macroservices, all right. So let us consult our checklist one last time. How are we doing on time? Because that was our history lesson. Y'all enjoy your history lesson? Yeah. Woo! All right, let's consult our checklist. We're going to go through each of these one at a time. There's literally 4 slides left. 5 if you include me, being narcissistic again at the end. So we're going to talk about these, and we're going to hear about what you have that works. We're going to talk about my suggestions. We're going to talk about all this other good stuff. This is the highly interactive part I warned you about. Okay, good. No one crawled under their seat. It happens. So, easy to develop and maintain. Here are some of the things I've learned. Are these good ideas? Maybe. Are they bad ideas? Perhaps. They've worked in the scale of the projects I've worked on. Things should be as big as they need to be. Right? You've got monoliths that say everything goes together. And there's advantages to that. What's a great advantage to everything being together? Everything's in proc, right? Yeah, everything's just right there. What's the advantage of breaking everything into smaller pieces? Easy to test, small, cohesive things you can wrap your head around, whole 9 yards. But sometimes when you're putting these things together, it doesn't make sense to isolate them. So I mentioned way at the beginning that I run a conference. I also happen to be the guy that writes the website. Notice I'm a back-end guy, not a front-end guy. The back-end is really awesome. The front-end looks awful. Go to devspaceconf.com. You'll agree with me. If you're talking about a conference setting, doing things like we made a sponsor microservice because our monolith just worked and we needed something to do. That's literally the first time I played around with microservices. Because it made sense. In the realm of the conference, everything about sponsors was isolated from everything else. They gave us money, we displayed their stuff, we gave them a booth, everybody was happy, right? Then we started to decide to work on the next one, and we were looking at speakers and sessions. Those are isolated things, right? You got a speaker, you got a session. They're so interconnected, it did not make sense to make them 2 separate objects. So they are together. They're part of the monolith still, because all of that stuff is so interconnected. There are a few other things we found we could spin off, et cetera, but that's what I mean by as big as it needs, or as big as it needs to be, right? Don't break everything up just for the sake of breaking everything up. Some things are so intrinsically entwined, leave them together, because they're going to talk to each other so much that it doesn't matter. And then the other side of that is isolate where it makes sense. Right? It made sense to isolate the sponsor stuff because nothing else touched it. So we could do things concurrently that way. And then my other big one is prefer share libraries over remote dependencies. That goes to that whole in process when you hit networks where things happen. It also fixes the problem of, I didn't say this during the actual history part, but sometimes I do. What is the new version of DLL hell? It's when you've got, well, NuGet package is actually pretty good about that, but I was more referring to when you have V1, V2, and V3 of microservices, and some of them talk to some, and you have to have concurrency that way. Right, so that's kind of where I get to prefer shared libraries. If I've got something working and I've compiled in the part that works, if I update the next part, it can just live with its compiled version until later. That's where I get that from. What do y'all got? What are your picks? What questions do you have? How do you make things easy to develop and maintain? We scared somebody off with the interactive portion. I warned you I was going to heckle y'all. Nothing? Nobody has any trip tips to make things easy to develop. Have you been beaten down by your jobs that much? Oh, okay, yeah. DevOps, that does it. CI/CD, yeah, okay. That CI/CD I more look at in my mind in the deployment sections, but it does come into the whole fail fast. So I'll give you that.
Bounded context.
What was that?
Bounded context within domain-driven design.
Failed in context of domain-driven design. Bounded context. Yeah? That's more documentation. And yes, documentation is important. I'm not sweeping that under the rug. But that's kind of, Swagger is a good idea because it forces you to document your stuff, because how many of you write documents in your code? Or write comments in your code? Okay, that's not a to-do or a hack. Serverless? I've seen serverless done very well. I've seen serverless done very poorly. We just got done with the project at my current job. I can't mention who, what, blah, 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 but we took a really old Windows Workflow Foundation application. Yeah, and we moved it to Azure Functions and stuff. And in that type of idea where we're literally doing a state machine, it works really well. But I've seen people say, let's do everything serverless and we don't need servers. And then you end up with the same thing that microservices do and that kind of DLL hell, that things are calling out of process so much that it dies down. So it depends on your use case. But yeah, if you don't have to worry about hardware, how many of you love playing with hardware? Okay, a few people raise their hands. How many of you have ever written a device driver? Few of you raised your hand, and notice that those two groups did not intersect. I've written a device driver. I hate hardware. Are we done with easy to develop and maintain? Anybody else want to yell something? Somebody said something over here that automation testing. That would go into testing, which is 2 slides from now.
Well, if you develop it as code, then it's a maintainable.
If your tests are code, then it's a maintainable product. This is very true. How many of you write tests when you first start a project? A few of you should at least raise your hand. Okay, out of those with your hands raised, how many of you actually fix the tests when you change the code, or do you just comment out the test? Hey, I've got entire test projects that are just unloaded because we decided to change the architecture. They're like, are there tests? Yes. Do the test compile? No, that was like 3 versions ago. What are you, crazy? AI copilots. Oh. I mean, if you want an excuse why your code doesn't work, at least then you can blame Bing. It's a lot easier than blaming yourself. I don't see the problem, and now we're going to go off on a philosophical rant for a second, but that's okay. It's not that I inherently don't like generative AI type stuff and whatnot. It's just that it's there enough to make you think it's useful, but it's not useful yet. Yeah, because there's too much massaging. It will get you 90% there. Now, I have some friends in the speaker world that have talked about, hey, I have this great idea for a talk, and I got to write an abstract, and I got to do all this, and they look at, writer's block. They look at that blank sheet of paper to start writing the initial pieces, and it's really hard. And you know what they did? They put the topic into ChatGPT and said, give me an abstract about this talk, and it spits something out. And all of them admit it's horrible, right, what comes out. But it puts something on the page that they can start revising. So there is, for things like generative AI and ChatGPT and Copilot and all that, there is uses for it. It's not at the point where you could be like, write this code, write this code, write this code. Because it falls back basically to the old stack search. Do you remember what the stack search was? This is both a joke and not a joke because it exists. Right, we're not good at prompt engineering yet. No, the stack search, it actually exists. You can find it online. It was from an XKCD comic where somebody joked that the way the stack search worked is it was a line of code you dropped in there if you needed to sort something. I'm sorry, it was the stack sort. What it would do is it would query from JavaScript, it would send a remote request to Stack Overflow, query sort, bring back the first accepted answer and paste that into your code, and then do it. Somebody actually made the stack sort website. It generally works within 3 tries. Literally, all it does is go to Stack Overflow, copy the code of the first accepted answer, and come back. But yeah, I mean, that's old school. That's generative AI for my generation. All right, how are we doing on time? All right, let's move on. We've still got, what, 30 minutes left? Yeah. Half hour for 4 slides. I think we can pull it off. Whew. All right. What are things that make things easy to test? Okay. Well, let me do my stuff, and then you can yell at me. Isolate where it makes sense, because, of course, the more isolated things are, the easier it is to get parts in there. Notice that some of this stuff is going to overlap, which is half the point of what I've learned. Preferred share libraries over remote dependencies, because then you can actually test the thing that's in there, and then when it comes out, you can have it. So, and one of my personal favorites is own your necessary remote dependencies. This is a big one for me. What do I mean by owning your own remote dependencies? No, but that's a great one. Well, when I say what are your ideas, yell that out again. So, how many of you have ever written database code? How many of you have written the infamous iDatabase class or interface or some version therein? We've all done it, right? And by the way, you should be. You need to interface that stuff, because a lot of stuff for testing, you don't actually want to hit the database because it's slow and clunky and makes your tests run very slow. You just want to say, this is what's going to get returned. Having said that, how many of you have ever written that iDatabase interface and targeted a database and then later was very happy because you actually changed out the database in the background? About 1%. Yeah, there's always a few people. And there's also people who work for larger companies where they're making a third-party tool, so it needs to work with SQL Server and Oracle and whatnot. So it's not like there aren't reasons for it. I always write that interface. I then always actually tested the SQL Server I'm hitting. But Chris, why are you testing the SQL Server? Don't you trust it works? Yes, I trust SQL Server works. You know what I don't trust? The SQL statements I typed into a string. Do want to hit the database to make sure those are returning what I think about every now and then. Do I need to run those tests every time? No, only when I need to change those because they're slow and they're clunky. However, there's times when that custom SQL statement is exactly what you need to get the performance. And it really is bad when you start changing things that all of a sudden it doesn't work. And there's no way to do it without owning your dependency, right? So own your dependency. What else you got? Somebody yelled something over there earlier. What? Have your own version of remote dependency so people don't break things when they update them, which goes back to kind of what I said last time of shared libraries and whatnot. So that's something I 100% agree with. Fork everything. No, I failed. Something testing principles. Oh, actually no testing principles. Yeah. How many of you just throw code at the wall and see what sticks? There's nothing wrong with that. But yeah, there is an actual nuance. There is a reason why test engineer or QA engineer is a job.
If you cannot own the remote dependencies, right now everybody's just mocking it, and the answer should be you shouldn't be the one mocking it. You you should let the other team that owns it give you the mocks.
Ooh, that's a good one. I like that. So there are times when you can't own your dependency. I 100% agree with that. And so her comment was, instead of you creating the mock, which, come on, we all create our own mocks. The team that creates the dependency should create the mock so that they can guarantee the mock matches what the dependency is. I really like that. Feasibly, how often does it happen? 0, right. But I love the idea. Like, if you could buy a product and say, here's how you interface our product, and by the way, here's a mocking library that works with it, that would be great. Going back to SQL Server, have you ever realized that there's no way to mock a SQL Server natively? If you use their appropriate classes the way Microsoft wants you to access it, there is no way to mock it. I've written a library that lets me mock it. It was very painful. Because progress. Right. What are your other testing tools?
Setting up like a test hierarchy, maybe having like in the base class, having like your shared common resources, you're not initializing it for like every single test class.
Yeah, I mean there is a nuance to just making the tests run faster by laying them out correctly, which is basically what you're getting at there. I kind of look at that along the lines of there are 2 types of tests. There's tests that you want to run often, right? These are the ones that auto run every time you compile. Every trick in the book to make that faster performance should be used. And then there's the ones when you check in code in the CI/CD pipeline. You don't care how long those take. So it kind of goes back and forth to where do I want the readability, where do I want the performance, et cetera, et cetera. But there is reusing the same stuff over and over. I never do stuff like that. You know why? I have entire libraries I've written. They're on GitHub. I can prove it. Where I generate random data for everything. So it's really hard to like cache a bunch of data somewhere at one point and hit it all. But that's because I've seen strange things come back from external sources. Very strange things. Selenium. I'm sorry. I mean, there's no good way to do front-end automated testing. Selenium's a tool. I'm not going to say a fine tool. It does it better than other ones I've played with. I've played with worse too. So.
Say documented test cases, because as a dev, I can make a test path.
There does need to be documented test cases. There needs to be, I like to think of my tests like they're a contract if you're doing it correctly, right? So you're saying, when I wrote this method, I'm claiming that this input will produce this output. If you use it this way, it will work. This is also sometimes known as happy path testing. But the reason I like that is because it makes you write very little code, and if you change things, you have very little that says, this part, which was the guarantee I gave myself at the beginning, has to work. And that's kind of like a contract with the code. That may be like a good documented test case, but if you're doing test-driven design correctly, this is not a TDD talk, in theory, you should only be writing tests for happy path and only write enough code to make the test pass. So I don't know, the test becomes the documentation in a way. But there's also large-scale enterprise projects where I've seen where it's like, yes, these are the formal business, this is business-driven development. These are the formal business cases. It must do this, and you can write tests around that, which then prove we're at the releasable state. So there's both sides of it. Kind of depends on which side you're on.
Behavior-driven tests, like from business, we take the behavior-driven test where they will give us what kind of behavior is expected, and we'll.
Yeah, that's what I was just talking about with the BDD. Yeah, it's behavior-driven tests, also sometimes called business-driven tests. And yeah, it's the problem with formal documents is that they are only accurate for about 2 seconds. And think about it. I mean, it's the same thing with code comments. How many of you write a code comment every now and then later change the code and actually update the code comment? Wow, a few of you claim you do. And then a few of you are going, yeah, that's a great idea. But that's right. We don't get paid to fix tech deck. What are you, crazy?
Having sensible error return.
Sensible error returns. Well, then why do you have an error in the first place? Come on now. Yeah, there's the implicit avoid null that's not written on the slide.
For me, a thing I like to do is to treat things as black boxes. So I will test each thing, especially the lower level it is, the more that things depend on it, really thoroughly. And then the further away from that I get, they're lighter tests. Because I assume this black box just works. It's already been tested. So I can just mock that and pretend, like thing goes here, right? And I don't have to test anything about that. Other than it receives the right data, like the hookup, as it were.
All right, and that's kind of on your remote dependencies. That's kind of where I got at with that, which is you need to be focusing on just the one area. But once you're past that layer, so to speak, yeah, it's stubbed out, black box out.
The one downside I've run into is when you change that underlying thing, and all these other tests are still great because you've mocked them to be a certain way, but the real thing has changed, and you forgot to update your mocks.
Well, that's why you have end-to-end tests and integration tests. You do have to have the tests that say, does the connection work? Separate your unit test from your integration test from your regression test from your every type of test, even if you don't actually do it in code. So, how many in most of the code libraries for .NET? There are ways to flag groups of tests as like these are integration, and so that you can only run portions of them. So it's okay to have a test class, which is this class, and just flag the independent ones. But yeah, definitely separate them out so that you can just run the necessary ones at the necessary time.
Actually run your test.
Actually run your test, yeah. But how can I run it when I unloaded the test project?
You can run it when you do your automated build, please have a test as well.
Yeah. Yeah, do actually run your test. Works. Then we shall ship your box. And thus Docker was born.
Tests are being used for coverage, and all that data is created nonsense in unit tests.
Oh, yeah.
That's why you are unloading it from your project.
Right. So that brings up another good one. How many of you have to deal with test coverage? Stop. What does required test coverage cause you to do? Write tests that touch code, not the test code. Yeah. We had somebody once tell us at one of my jobs, but we have to have at least 90% code coverage on our tests. And I said, I can get you 90% code coverage. I won't test a single thing. But I can hit every single if statement in that function. Come on.
Would you say that it's at least like necessary, if not sufficient, to have good quote-unquote tests? I mean, if you're not even running the code, right, in your test, then you're missing something, right?
So I'm not saying it's not important to look at your code coverage occasionally. Because every now and then you can see, oh, hey, there's this huge gap here that we're not looking at, which means either it's code we can get rid of or we need to find some way to test it. I'm not saying code coverage isn't a nice tool to have. I'm saying don't target certain levels of code coverage because it leads you to write code that covers, or test that covers code, not code that tests code. And yes, I know I realize I just said potato when you said potato, but all right, let's go ahead and move on to the next one. Anybody have a last bit of thing on test I want? Like you said one more thing, but or did I address it already? Okay, good. Appropriate logging. Yeah. I just write the code. I don't have to deal with it once it's in the field. Yeah, we've and logging is almost its own talk. But yes, please at least have some sort of rudimentary log somewhere. You will thank yourself later. Because sometimes when it's deployed on the server, you can't put it into debug mode and step through the code. As much as you want to, you can't do that.
You don't test
Yeah. Excuse me. All right, easy to install and deploy. One of my personal favorites here is that Shiny is fragile. What do I mean by Shiny is fragile? The new, the new latest and greatest stuff generally was written for a very specific use case and is not meant for whatever you're about to do to it. Remember the slide where I said I should have put a Kubernetes logo on it? I'm not saying Kubernetes now isn't a mature technology that has gone through a lot of stuff, et cetera, et cetera. When it was first written, it was written to solve a very specific use case at a very specific company that was nice enough to happen to say, hey, we came up with this idea if you want to look at it. And a lot of people used it with widely different use cases that it wasn't meant to do because it was the new shiny thing, and OMG, Amazon released something. It was Amazon that did Kubernetes, right? No, Google. Yeah, Google. We have to use it because it's what the Google engineers do. No, they had a very specific use case, which is why they created a very specific product. Now,
Didn't they write their own operating system?
several operating systems. Over time, it has been genericized and refined, and it is actually a decent tool that can do other things. But, you know, that's one of those things you have to keep in mind with a new shiny technology is that it's generally, it wasn't written for you.
Well, if you're using Shiny in the derogatory, you're obviously not Firefly fan. So, because Shiny is like the best thing you can have. Shiny. No, nerd.
I mean, yes, I got your reference. Thank you.
Shiny, Cap, come on.
It's been a long time since I've seen Firefly, though. All right, and then the other one is that DevOps enough to make your life easier. It shouldn't be a full-time job. I like to say in most of the teams I work on, everybody is like a 10% DevOps engineer. You should know how the pipelines work. You should be able to go in there to tweak something. Everybody should keep everything flowing. But if you hit the point where you're hiring people to just do nothing but DevOps, there's a problem. Occasionally, teams get so big you end up having to do that, and that's okay. But why do I say it should be split across the entire dev team in small amounts and not have an engineer who does it? Because again, that's not my problem anymore. It's the DevOps guy's problem. It no longer fixes the problem. It becomes a scapegoat. I kick the problem down the road to him, and I go away. It comes back into like a dog fooding argument type thing as well. You know, it's like if you're not using it and living it, sometimes it's hard to actually write it. So that's why I like to say DevOps should be spread as a small part of everybody, not an independent engineer. There are times you can't do that. I understand that. All right, what was it? We're on deploy, right? Yeah. What are your deployment tricks? Generally, there's not as many deployment tricks as. Keep your pipeline simple. Okay. Yeah. I mean, your pipeline should be just the steps you need it to actually do something. If your pipeline's 500 steps long, why is your program at a point where you need 500 steps to actually do something? Sure, grab it from source code. Sure, build it. Sure, run it through a tester. Sure, package it. Sure, throw it up into wherever you're deploying it to. What other steps are you adding past that? Seriously, if you've got more steps than that, what are they? Yeah. Database deployments. How often does your database change that you're doing a database deployment? Every sprint. Wow. Code review in the pipeline. I did work at a place once where we had the CI/CD set up for everything, but for the release build to actually go to prod, it stopped and you had to physically press a button. Well, not a physical button, but you had to go to the website and say, I confirm that I see all the tests pass. This is the time to do it now before we would actually do the last step. So I've seen stuff like that done. I've never seen it as a actual some way to force somebody to do a code review of the code that goes into it. Because how do you force somebody to read the code? It's like, what is line 53 of this file that changed? A PR on the commit? Okay, yeah, I mean, I've seen stuff like that, yeah.
Put your deployment scripts in source control.
But my deployment scripts in source control depends on, I like the idea because at least then you can see if there's a change and you can track changes, and always tracking changes is good. There are places where you can't get a script of what the deployment is. Like if you're doing stuff in ADO, sometimes it's just, I think, actually no, ADO now you can say reverse engineer the YAML and give it to me. So I guess there's always a way to do it, but sometimes it's just not worth that effort.
I would also decouple getting files out there or services running and necessarily getting accessed or being activated as what is, visible to users, right? So like in a previous job, we worked on a deployment where it would copy the files to the server, but actually switching the version that the Nginx server pointed to, which folder it was pointing to, was a separate deployment, right? So rollbacks were super easy because they're just files and we just switch it back and forth, right?
Right, and a lot of stuff in Azure has the same idea. It's what's called a VIP, or a VIP switch, which is you give it a couple deployment slots and you can update the one slot. It's also how graphics cards work, by the way, but we'll get that's separate. You update everything in one area, and then you can test it actually in the environment. And then when you're ready for it to go live, all it does is it swaps the virtual IP, so it suddenly points to the new location. And then you have the old version there in case something goes bad that you can revert back to. So that's a really good, but that's more of a deployment technique. Are we on deploy? We are on deploy. We spent so long on testing. I was Feature switches. Feature switches are awesome, yeah, where you can pre-deploy code and then wait for whenever it's ready to actually tell it to come on, yeah. Not necessarily. Infrastructure as code? Ooh. Well, I mean, I guess I did say the YAML word, so I had it coming to me. What? I mean, you could just buy a new server, put it on the server, and just put the new server in place. No. Run NuGet in your network. I've done that. I don't know if it's that much of a... Oh, you're excused. Yeah, I have a love-hate relationship with NuGet. I really do. I love it as a concept, but then I also love it in the fact that even on Microsoft packages, it's like, okay, I need this. Great, but you need this dependency. Cool, but this one needs this different dependency. Why did you do this to me? Yeah, so, but that's why we don't have a DevOps guy, because that would be his problem. No. Do I see continuous deployment to prod as a goal? No. I mean, I don't think it's a bad thing. And I don't think, how many of you here are of the camp of don't deploy code on Friday? Why are you scared of your code? Dead serious. Yes, yes. Because I am the dev. That's why I'm scared of my code. No. There have been times where I've worked at jobs and we've deployed 3 times on a Friday, no problem. Oh, wait, emergency hotfix, oh, wait, feature, oh, wait, because we weren't scared of our deployed content or our code, and we had good tests and whatnot. If you're scared to deploy on Friday, really look at what's going on in your process as to why. There's probably some code smells and some red flags somewhere. How do you convince the business leader? With a 2x4.
It's about risk management. So you're not
Why are they working over? Why are the people who are using the product working over the weekend? I gave you a free weekend. Yeah.
It's nice being introduced to DevOps guy because you guys both shout start.
No. All right, we got 5 minutes left. Let's get to the last one real quick. Fast and performant. Before in process, when possible, that's when we start talking about all the speeds and everything. Batch out process requests when possible. How many of you realize that there are limits on, like, if you send things out through web browsers, parallelize? My brain just went. Bleh. It's a little warmer. Batch out of process requests when possible. So if you're going to make a database call, if you can send all 3 queries and go through them, so it's one round trip. That helps. Parallelize out with process. That's where microservices got something right. You can batch out to multiple places. Just keep in mind that there's limits on requests in web browsers where sometimes you're not getting the parallelization you think you are, and statically load when possible so that it's just in memory and happy. What are the other performance tricks? Docker swarming. I don't know if I'd ever use the word Docker and performant in the same sentence, but Kubernetes. That's my response. I know, I pick on Kubernetes a lot, but geolocation's a good one. That fixes that whole, San Francisco to New York problem. There was also on that slide San Francisco to Australia, and it was redonkulous.
So what's your take on like using S3 versus local test versus network test for things that you need to persist?
I mean, I'm a big database guy, I'm a big backend guy, so I normally would have things next to each other as much as possible. You could use the cloud just like make sure you're in the same data center, and even if you're doing geolocated, the way you get the replication to work. I don't know, because I've never thought about it in that way. It's normally always just there's the cloud side and the client side, and making sure the correct pieces are together. And to me, that means everything on the cloud side, and then you just push down a packet, because internet speeds are fast once they start, typically. There was a big deal for a while where everyone was like, oh, we have all this computing power right here. We should send everything to happen down here. And well, now you're doing all your computation on a client device, and you're never sure what the capabilities are, and it could become a good experience or a bad experience. So I don't know. It's just kind of a weird one.
I would say it's important to have a good hierarchy of priorities of like what is the point of the task you're trying to achieve, to prioritize loading that, right, versus what is ancillary to the experience that would enhance it but can wait a minute to load after the main stuff is in.
Yeah, and that's true, and that kind of goes back to the whole Unix philosophy, and it was also Windows Metro design of do one thing and do it well. So make sure that you're doing your thing, and then if you've got to call out to other things. And then, yeah, there's a point in time where you got to do performance and getting everything back together. And we're out of time. Let me throw that up real quick so y'all can find me. I will be hanging around if you want to talk and throw other things at me. But, yeah, you can talk more about deployment, or what was it? We were in the... Yeah, do all that.